Hey everybody, welcome back to the workshop, and this is going to be in a flea market finds episode, and not quite a flea market finds. This was a pick. This was a machine shop that had invited me to come in. They knew I was buying used tools because one of their employees has bought tools from me, and they basically had a room where they were putting a lot of surplus equipment over the years. There was even stuff in there that was old enough that they had pretty much inherited it when they had bought like equipment years ago, and it came with a toolbox or whatever. So got quite a good sized load of tools here. We're going to try and go pretty quick through them. Again, I'm trying to keep these videos a little bit shorter and sweeter. So let's dive right in. So they brought me into a large break room area where they had a big conference table, and it was just covered with stuff. And basically I ended up buying just about everything they had there in one lot. And there's all kinds of stuff in here. There's some stuff that's broken. I even got some empty cases. You know, they didn't really care if I took it or leave it. So some of this stuff I haven't even really taken a good look at yet. So this is a Fowler bore gauge. Okay, that seems to be working fine. Somebody used a Sharpie or permanent marker or something and marked. They kind of put limits on here. But what's nice is it has even the little tiny washers, spacer washers are here. It looks like maybe one's missing, but it's almost looking like this is a complete set. That's nice, even though it's old. Oh, here's an even older one. And again, seems to be working perfectly fine. Might be missing one here. And these are different style posts than that last one, so... Oh, actually that's probably the post that's in here. Alright. Look at it. It's so old, the glue that held these in place has dried out and failed. This was even glued down here and it moved. I don't even remember what's in here. I'm guessing big vernier calipers. Oh no, actually, Helios dial calipers. Face is kind of yellowed. It's funny, these actually say Helios here, but I think they actually are marked, they marked Fowler on the face. So apparently Fowler had these made for them by the German company Helios. And these are actually feeling pretty good. They're repeating. Nice. Oh, nice. Repeating to 0 all through the range. Stare at depth mic. Oh, it's a blade depth mic. It looks like it's a... It looks like we're missing one, because 1, 2, 3, 4. There's 5 blades in here. And I'm sure this probably was originally a 0 to 6. This is heavy. What's in here? Oh yeah, this is this really old digital drop indicator, I think. What this ended up being. It's a Mitutoyo Surf Test, model 211. Betcha this thing was expensive when it was new. Alright, I'm gonna worry about that for now. This is clearly marked out of service, so they had some issue with this. Oh boy, that's an early one. An old Starrett multi-anvil micrometer, and the ratchet stop works on it. Somebody could use that for part corrosion on the anvils. Well, I'm going to be hard pressed to get any money for that. 0 to 6 inch depth micrometer. I am not familiar with. This is an unusual one. I've never seen one that looked like this. So, is this Chinesium? I am not seeing a manufacturer's name on this thing. Might be under the calibration sticker. I think I'm going to peel that calibration sticker off. Usually I try and leave them on, but I'm just that curious to see whether or not there's a name underneath this. Yep, there we go. Got something here. SPI. All right. Hey, so before I move on to the next group of items, I just wanted to get back to this Mitutoyo Surf Test 211 and talk about it briefly. This is, I did some research and found out that this is a profileometer. This is actually a precision instrument for measuring the surface roughness of a product. So now I remember that the guys at the shop told me that they had purchased this for a particular contract that they had, a particular customer that insisted that they use one of these to determine the finished product of surface roughness on the parts that they were making, and that they hadn't used it since they had that contract, and it just had been storage, so they considered it surplus equipment. Anyways, it's really kind of cool the way this works. So this is the probe head, and this is the actual probe right here. These are actually just, these probes are pretty expensive. And the way it works is on the underside here, right here, there is a tiny stylus. Almost looks like a phonograph needle. I'm assuming it's made out of steel or carbide. What happens is when you place this on the surface that you're going to test, and you start the unit, it actually, this little cylinder right here moves in and out. There's a mechanism inside here that literally drags this stylus across the surface, and then it resets. And when it drags across the surface, it kind of is, you know, imagine taking your fingernail and dragging it across the surface, and you could feel those vibrations. Well, essentially that's what this thing is doing. And you know, the rougher the surface, the vibrations, the frequency of the vibration is going to be different, right? And so that's what this thing is doing. And it can measure in I believe micro inches, so it's pretty accurate. The problem with this particular one is that I have no way of proofing if it works correctly. For starters, it looks like from what I've seen online, to use this properly, what you're supposed to do is this is supposed to be mounted on a height gauge or comparator stand, not unlike, you know, a drop, not unlike a comparator. This that was in the box, it now is apparent to me, because of the spacing of the holes and the way it's shaped, that this would fit right on the back here. There's two threaded holes in the back, and I can actually see a ghost outline on the back here where this was screwed on. So the screws are missing, but this should be screwed on the back here like this. And then of course that gives us a post to mount it in a comparator stand, right? So again, to properly test this, I would need to have this mounted on a comparator stand on the surface plate, and then you would take your surface that you want to test this on. When I turned this on, all I got was flashing and an E for error. I did determine that it turns out that was normal, and that was because I didn't have the probe. When you push up on this, see how this moves? Basically, the system knows whether or not the probe is in contact with something based on this. So if I just do that, it'll do the error, but I found out that if I actually have it touching something. So I'm just going to use this thin piece of metal I have here on the bench, and I'm going to put this down, and so that's now moving up on the bench like that. So now that's in contact. I'm going to turn it on. So this over here is micro inches, and I'm going to hit start, and what's going to happen is that's going to actually move. So it's moving a tiny bit. And now it's going back to its start position. And it's telling me that this surface has 45 micro inches of roughness. So one of the things I can do, I don't know what the surface is. What was supposed to be with this thing, I think, is a reference surface that probably came with this to allow you to calibrate and test this and make sure it's working correctly. But what I can do is I can repeat the test and just see what we get for a roughness test on the second try. .44. So that's within plus or minus 1 micro-inch. I'm probably thinking that there is a tolerance that is acceptable. I don't know what it might be. 43. It's dropping 1 micro-inch every time I test it. I'm thinking that's probably not good. Oh, it did 43 again that time. I wonder if you're supposed to reset it after every time you do it. And that 003, I wonder if that means that I tested that 3 times. And a 40. It dropped quite a bit now. So I don't know whether or not this is just not a good test piece, or whether or not there's an issue with this thing. So the last thing I did have that I could try is I have this old Taylor Hobson Calibration Standard for a very, very early surf test that I found at an estate that I didn't end up buying because the thing was, it was a really big, clunky, old electronic thing, and I think it was missing parts. You know, if somebody like Tom Lipton was local to me, I probably would have snagged that thing just to give it to him so he could have fun with it, because he would probably get a kick out of that deal. Anyways, so I'm looking at this. It's kind of confusing to me how this standard works, even because on one side it seems pretty clear. One window it says 1.18 microinches. Yeah, 1.18 microinches. It's also given in micrometers, 0.030 micrometers, so I guess that would be in the metric equivalent, right? It says total height 1.18, so I'm assuming that that's the height of the ridges from the surface. Like from the, you know, if you're looking at it as almost like a sine wave from the trough to the peaks. This other side clearly has damage, unfortunately, to it. But the areas that aren't damaged, maybe I could still use for a test. But it's weird because it says 84 microinches up top, and then down below it says 15.2 microinches. So I don't know, are they actually saying that there's 2 different surfaces there? So of course my problem with this has got a certain height above my table here, which is in a surface plate, so right off the bat I'm probably not, I might have testing issues here. Oh, 2 microinches. How do you like them apples? That's only 0.2 of a microinch off. That's not too shabby. I think if I hold this down it does data. I don't know what that is. Oh, I bet you I know what that is. I bet you there's a port on the back here. I bet you this can be hooked up to a computer to log the test results. Try it again, just see if it changes any. Oh, see? Now it's saying 4 microinches. Oh, you know what I did? When I was picking this up, I moved this. So that's probably not good. Oh, back to 2 microinches. Alright, well, enough of that. We got plenty of other tools to look at, but I just thought you guys might find that kind of interesting. Oh, one last thought on surface roughness. This is a Microfinish Comparator. This particular one is made by GAR. GAR Electroforming of Augusta Drive, Danbury, Connecticut. So this is kind of a neat thing. And what this is this is just like a little sample plate of all different types of surfaces, milled, ground, lapped, polished, are all on here. And this, believe it or not, the instructions for this are you basically place one of these blocks adjacent to the surface that you're comparing it to, and then you use your fingernail and you rub your fingernail along this surface and compare the feel of this to the feel of what you're testing, and you figure out whether or not you've got a comparable surface. So it's kind of a neat thing, you know, and I guess you can get pretty close with one of these. But I was just kind of curious because inside here there's a chart and it tells you, like, for the different surfaces what roughly the micro-inch rating should be. So for instance, honed, lapped, or polished surfaces should be 2, 4, or 8 micro-inches in roughness. Whereas you go to the other end of the spectrum, a milled surface could be anywhere from 63 to 500 micro-inches. That being said, so 63, 125, 250, and 500. So I'm thinking maybe that's on here. There are 4 different examples of milled. Yeah, 500M would be a milled surface. Yep, 250M, 125M. Okay, I'm seeing that on here. All right. So, for giggles, let's see what happens if we take our fancy schmancy profileometer and we run its little tiny fingernail across the 500 milled surface. Oh, I think I'm gonna run out of position here. Yeah, that's, oops. Yeah, error. Yeah, didn't like that. Okay. Maybe if I did one of the ones on this end. Let's see. Alright, so this one right here on the end is a 63G. That means it's a 63 ground surface. That should be 63 micro inches ground. 50. Well, considering the relative crudeness of this setup I've got going here, might not be too bad. Look at that. Repeatability of 50. 49. Not bad. These results seem a little bit better than what I was getting before on the Taylor Hobson. This is, at the other end here, is 500 ST. I don't know what ST is. Shaped or turned? Okay. Parts milled on a shaper. That would indicate this comparator's got some age to it, right? 500. I wonder if that's out of range. 32 shaped or turned. 28. See? Not bad. Alright. So, I would say it works. Just don't know if it works entirely 100% properly.